Welcome to the latest episode of our deep dive into LED screens and what goes on behind the scenes. This week, we explore the innovative British technology from DigiLED UK that is quietly saving customers thousands of pounds and ton after ton of CO2. Ross, Robin, over to you.
I want you to picture something with me for a second. Imagine you're walking past a huge sports stadium late at night. Or, maybe you're in the middle of the big city Times Square Piccadilly Circus. But it's 3 in the morning. The crowds are all gone. The show's over.
It's a bit of an eerie feeling, isn't it? Those places are so full of noise and light, but at that hour, they're just silent.
Exactly.
Yeah.
But if you look up at those giant LED screens, the ones wrapped around the buildings, they look black. They look like they're off, asleep. But if you get close enough, if it's really quiet, you can hear them. They're humming.
And that hum, that's the sound of money burning.
And that is the hook for today's deep dive. We're looking at a stack of research about what some are calling a dirty secret in the AV industry. Turns out these giant LED screens are almost never actually turned off.
Right. Even when they look pitch black, they're often burning a significant amount of electricity.
And we're not talking about the little standby light on your TV at home.
No. This is industrial scale power consumption. It's often called vampire power. And the sources we've got today suggest it's creating this huge, invisible dent in the global energy grid.
So today, we're unpacking a technology that claims to solve this very problem. It's called ZEUS,
Which stands for Zero Energy Usage System.
a very cool name for what is, well, essentially a switch. But as we dug into the patents and the engineering reports from the developer, a British company called DigiLED, it became really clear this isn't just about a simple toggle.
Not at all.
It's a story about physics, about a kind of a massive design flaw in our modern infrastructure, and about how hard it actually is to just stop.
It really is a fascinating paradox. You have these venues that are empty, silent, dark, yet their electricity meters are spinning like they're running a small factory.
Let's start with this vampire problem, because the numbers in these reports were, honestly, they were pretty shocking to me.
Yeah.
I think most of us assume black screen just means off.
And that's the big misconception. The data points show that a typical LED screen in standby, which is the industry term for just displaying black, is still consuming about 11 to 17% of its maximum power.
Okay, let's just pause on that for a second. 17%. That's nearly a fifth of its total capacity doing nothing.
To put that in context, think about your car. Imagine you drive home, you park, you turn the key to off, but instead of the engine shutting down, it just drops to an idle, sits there revving at 1,000 RPM
The whole night.
the whole night. You go inside, have dinner, go to sleep, and your car's just sitting in the driveway burning fuel just so it's ready to go the second you get in the next morning.
That would be insane. No one would ever buy a car designed like that.
But that is exactly how we've designed large-scale digital displays for the last 20 years. The source material notes that when these screens are fully operational playing ads showing the store, they're usually running at about 40% of their max power.
Wait, only 40% when they're actually working?
Right, because you rarely have a screen that's 100% white at 100% brightness. So doing work is 40%, doing nothing is 17%.
That gap is terrifyingly small. You're burning almost half the energy it takes to run the show just to sit there and wait for it.
Precisely, that gap. It's pure waste. And when you look at how these things are used, the waste period is actually the dominant state of the machine.
This is that machine that does work idea from the notes.
Exactly. An office building doesn't need its video wall on at 3 in the morning, but the sports venues are the really stark example. The sources say that some stadiums might be empty for, get this, 73% of the year.
73%. That is a staggering amount of downtime.
So for nearly 3/4 of the year, that hardware is just sitting there, showing a black screen to an empty parking lot and burning up to 17% of its power budget. Every single hour. It's a huge financial leak.
Okay, so this is where I have to ask the really simple question. Why don't they just pull the plug? Or, install a giant breaker switch? If I leave a light on, I don't need a complex circuit board. I just flip the switch. Why is this so complicated?
And that is the multi-million-dollar question. It's why we're doing this deep dive. It's not laziness, it's physics. Specifically, a phenomenon called inrush current.
Inrush current. It sounds like a heavy metal band.
It's certainly destructive enough. Think of a giant LED screen, not like a TV, but like a massive industrial machine. It's made up of hundreds, sometimes thousands, of individual panels, and each one of those has its own power supply unit, a PSU.
So it's thousands of little power supplies all wired together.
Exactly. And inside each of those are components called capacitors. Their job is to store up energy. Now, when a screen has been truly off, those capacitors are empty. They're
I
scarcity.
think I see where this is going.
If you installed one giant master switch and you flipped it on, all of those thousands of empty capacitors would try to draw power at the exact same microsecond.
Like opening the gates at a concert and 10,000 people all trying to get through one door at the same time.
That's a perfect analogy. It creates this enormous spike in electrical demand. And the sources are pretty dramatic about this. They mention that trying to turn on a screen that size all at once would result in, and I'm quoting here, a substation blowing.
Wow. So not just tripping a breaker in the basement.
No, we're talking about taking out the neighborhood grid. It creates an overload that can damage the local power distribution, sure, but it can also literally melt components inside the screen itself.
So that's why they've been so scared to turn them off. They keep them in standby, paying for that 17% waste because the alternative is so dangerous.
It's a classic rock and a hard place situation. Pay the ransom to the electric company or risk destroying your $1 million screen.
Until now. And this is where the Zeus technology comes in.
This is the solution.
Right. And looking at the specs, it's surprisingly small. It's not some giant lever from a Frankenstein movie.
No, quite the opposite. It's a small printed circuit board, a PCB, about the size of a credit card.
And one of these little cards gets mounted to every single power supply in the screen.
Correct. You can retrofit them or install them from the start. And this is the clever part. These cards allow the system to physically disconnect the AC power right at the unit level. That brings the power usage down to true zero.
Not standby, not black video.
Zero.
But what about the explosion problem? If they turn it back on, don't you still have that rush through the door issue?
And that is the genius of the patent. It uses what's called a soft start sequence. Instead of waking everything up at once, Zeus acts like a traffic controller. It wakes up the panels in a staggered sequence.
Like a wave going across the screen.
Essentially, the source describes a millisecond sequence. If your screen has, say, 64 panels, Zeus powers them up one by one over a very short period. To the human eye, the screen just turns on. But to the electrical grid, it's a gentle ramp up, not a vertical spike.
So it turns the stampede into an orderly queue.
Precisely. It manages the inrush current so the grid barely even notices. And because they solved the startup problem, they unlock the ability to actually finally turn it off.
I love that. It's such an elegant engineering fix. It's not about finding more power. It's just about controlling the flow. Now, I want to talk about where this idea even came from, because the origin story is pretty relatable.
It is. It starts with an inventor named Tom Mudd, who's based in Hove in the UK.
And the timeline here is really important. This wasn't developed in some lab 20 years ago. The idea was conceived during the COVID-19 pandemic.
Which makes perfect sense, doesn't it? Suddenly, in 2020, you had a world where every stadium, every concert venue, every office was just empty.
Ghost towns.
Yeah.
But the screens were still on.
Humming away in standby. The source notes that the pandemic really highlighted what they called this terrible energy wastage. You had venue owners who were bleeding cash, but they were still paying these massive electric bills because they were afraid to turn the screens off.
It's that classic necessity is the mother of invention moment. Tom Mudd sees this unbelievable waste lights on for nobody and realizes the whole barrier is just this inrush current problem.
So he designs a way around it, and he didn't just design it, he patented it. It's now a protected technology in the UK, and it's extending to the US and worldwide. They're exporting it from Hove to New York, San Diego, Kuwait.
It's a great example of innovation going global. But let's get down to brass tacks. Does it actually save money? Because saving the planet is great, but these venues, they really care about the bottom line.
And the case studies are very compelling on both fronts. Let's look at the Yorkshire County Cricket Club, or YCCC.
Okay, a cricket club.
They have a 100 square meter scoreboard. Now that's a decent size. Since they installed Zeus back in October 2023, the data shows they've saved over 37,000 pounds.
37,240 pounds just from turning it off properly.
Yes.
Furthermore, they prevented 33,782 kilograms of carbon from entering the atmosphere.
Their director of ops, a guy named Sam Hinchliffe, is quoted just calling it a no-brainer. That sum of over 37,000 pounds, that represents capital that is entirely preserved.
Right, money that didn't just vanish into thin air.
Exactly. In the context of a sports club, that's the equivalent of a full-time staff member's salary, or a substantial reinvestment into facility maintenance. And it's entirely recouped from what would otherwise be wasted ambient energy.
Just burning money for a screen nobody is looking at.
Precisely.
It just shows how much that vampire power really adds up.
And that's just one screen. Look at the O2 Arena in London.
Which is, of course, huge.
They were customer number one. They've been operating Zeus since September 2022. They have 8 screens using the tech. Now, we don't have their exact savings figure, but you can imagine the scale.
Stuart Edwards, the tech director there, pointed out something really crucial in the notes. He said it helps them quantify emissions. We should come back to that regulatory stuff, but I want to stick on the efficiency for a second.
Sure.
I noticed this really interesting comparison they made. They compared this leap to the aviation industry.
Yes, this really helps contextualize how big a deal this is. The aviation industry is, obsessed with efficiency. They spend billions fighting for a 0.5% or maybe a 1% gain in fuel consumption.
Right, they're shaving ounces off seats just to save a few drops of fuel.
Because globally, 1% is millions of dollars. Now, compare that to Zeus. The sources claim that Zeus can introduce 20 times more advantage. In some of their calculations, they found it made a screen roughly 54% cheaper to run annually.
54%.
Imagine if an airline announced a plane that was 54% cheaper to fly. It would completely revolutionize the economy. It would be front-page news everywhere.
It really shows how much low-hanging fruit is still out there in our infrastructure.
Yeah.
We just accept these inefficiencies, like standby mode, because we think they're necessary.
Exactly. When you remove that perceived necessity, the gains are huge. It challenges this whole mindset of readiness. We want everything ready in a millisecond. But Sam Hinchliffe asks, does the scoreboard really need to be ready at 4 a.m. on a Tuesday in February?
Speaking of February,
Yeah.
I'm going to play devil's advocate for a second. We talked about why they keep them on the inrush current, but isn't there another reason? Electronics hate the cold and damp.
You've spotted the overwintering issue. And yeah, that is a legitimate concern. The documentation actually addresses it directly.
Because if I turn off a screen in a stadium in Chicago or Manchester in the middle of January, what happens when it gets to minus 10 degrees?
Condensation. As the temperature swings, moisture forms on the circuit boards. And if you power it back on while it's damp, pop, you get corrosion, a short circuit.
So the standby heat was also acting like a very, very expensive dehumidifier.
It was. So the critique would be, sure, Zeus saves power, but it ruins my expensive hardware by letting it freeze.
So how do they get around that?
The system is smarter than just a simple off switch. It allows for overwintering protocols. Because Zeus is a circuit board, it can intelligently manage the screen, it can wake it up periodically, or keep it in a very, very low power state just to generate enough warmth to prevent condensation without the full standby drain.
So it's active management versus just passive waste. That protects the hardware.
Precisely. And there's another safety feature they mentioned called pyro protection.
Which sounds cool, but I'm guessing it means it prevents fires.
It does, and this is a serious business. The ability to completely cut the AC power removes what's called the electrical potential from the device.
So in plain English.
If a device has power running to it, even in standby, there's energy there. If a component fails or a seal breaks and water gets in, that energy can arc. It can create heat. It can start a fire.
And if the stadium's empty?
Nobody would notice until it's too late. A screen in standby could theoretically catch fire. A screen with zero power cannot. It's inert.
That seems like a pretty big deal for insurance companies, too.
Absolutely. And it's worth noting this isn't some standalone system you have to manage manually. The source mentions it integrates with all the major control systems, Crestron, Extron, AMX.
So it just plugs into the building's existing brain.
Correct. It becomes part of the automated flow. You program the schedule, and Zeus just handles the physics of the switching safely.
I want to zoom out a bit. We've covered the tech, the savings, the safety. But there's a regulatory angle here. You mentioned the O2 Arena liking the data. Why is that data so important?
No, it's not just for bragging rights. This connects to the bigger picture of corporate responsibility and, frankly, the law. The sources specifically call out the EU's new Green Claims Directive.
The Green Claims Directive, is that the thing to stop greenwashing?
Exactly that. For years, companies could just say we're eco-friendly based on vague estimates. But the regulations are getting much tighter. You now need demonstrable, quantifiable data.
So you can't just say, we turn our screens off. You have to actually prove it.
And you have to prove what that saves.
Huh.
Zeus provides the exact metrics needed for things like the GHG protocol and the CSRD, that's the Corporate Sustainability Reporting Directive.
So it's not just an electrical switch, it's an audit trail.
That is a perfect way to put it. Because it's digital, it can log exactly when power was cut and for how long. It moves the conversation from, well, I think we saved energy, to here is the audit log showing exactly how many kilowatts we did not use.
For a massive corporation that owns a stadium, that kind of reporting must be gold. It keeps them compliant and proves they aren't just making things up.
It really is. It validates the idea that major innovation doesn't always have to be a new fusion reactor. Sometimes the biggest impact comes from just fixing a loophole in how we turn things on.
So, to recap, we've got an inventor in Hove fixing a global energy leak with a smart credit card-sized circuit board. It saves money, saves carbon, prevents fires, and helps you fill out your EU paperwork.
A very efficient summary.
I want to wrap up with a thought that really struck me when I was reading the patent section. The source mentioned that the patent wording was very carefully crafted to extend beyond just screens.
Yes, that caught my eye too.
They mentioned IT infrastructure, transport, industrial warehousing.
Think about the implications of that for a second. We live in a world of smart everything. Smart cities, massive server farms, automated warehouses. All of these systems run on high-power electronics.
And I bet a lot of them are sitting in standby because of this exact same inrush current problem.
It's highly probable. Think about a server farm. The power consumption is astronomical. What if you could apply this soft start, true off philosophy to sections of a server farm during low traffic hours, or to the lighting grid of a smart highway?
Exactly. We talk about the energy crisis all the time. We talk about building more wind farms and solar panels. But what if a huge chunk of the world's energy crisis is actually just waiting to be switched off?
It forces you to rethink the whole definition of demand. We assume all the energy we use is necessary, but what this technology shows us is that maybe 17% of it is just fear of flipping a switch.
A sobering thought to leave you with. Next time you see a black screen in a stadium or a dark office building, just ask yourself, is it sleeping or is it feeding? Thanks for diving in with us.
A pleasure as always.
We'll see you next time.
Thank you for listening to the deep dive on DigiLed Zeus. If you'd like to know more about Zeus, please head to digiled.com/Zeus. That's digiled.com/Zeus.